I'm Sai, and this is Gayathri. We work at a large content platform, loosely rhyming with PEPR platforms. Not allowed to say the name, not allowed to put it on the slides. You can see a disclaimer at the bottom that says all of these are my own opinion and Gayathri's opinions and not our employers. So that's what I'm authorized to say, and that's all we're going to say there. So why this talk and why now? Over the past 18 months, a few things have converged. One of them being regulations. We finally have clarity from governments. That's a big deal. Right? We know what we need to build, and the industry has started working towards standardization. Again, a really large thing. And we are seeing deployment at the industry level. You might have seen a couple of news articles about OpenAI and Google rolling out different AI provenance technologies like C2PA, SynthID, IPTC, et cetera. And that makes for this talk to be very timely because AI provenance is now required infrastructure. And the problem we are discussing today is that that infrastructure has not been put through a fully privacy engineering lens yet. So what's our hypothesis here? I'm saying AI transparency mechanisms are not inherently privacy neutral. And we'll see why that is in a couple of minutes. Gayathri is going to walk us through a real-world use case. But in short, the same metadata that is used to understand and identify whether something was AI generated or not can also be used to identify the creator of that particular thing. The disclosure that is required is just whether something's AI or not, but the metadata itself carries so much more that it can be used to identify the people or the organizations behind said generation. I've mentioned this technology once before in this talk, C2PA. It stands for Coalition for Content Provenance and Authenticity. I still maintain they should have called it CCPA, just to add more to the confusion. But it's a cross-industry standards body that defines specification for content provenance, not just AI provenance, all content provenance. But it's picked up steam in the last few months because multiple large-scale providers like Google and OpenAI are behind it. Meta's on the steering committee as well. So we've been getting some industry traction on it, and that's going to be the core focus of today's talk. The metadata that we are referring to is to provide a secure, cryptographically secure. Crypto bros don't come after me after this. But it's cryptographically secure, tamper-evident digital nutrition label, essentially saying a bunch of things around like what the AI content was and who created it and what kind of changes were made and so on. So to give you a quick rundown of the fields, I cherry-picked these fields because these fields prove my point a lot better than the other fields. But we'll start with these ones. It has a signer certificate, which tells you who signed it. It has timestamps on what kind of changes were made and when they were made. It has the claim generator tool, which tells you whether it was created by Gemini or DALL-E or whatever. And it has the entire edit history of what all changes were made to this AI content. It also allows for free-form fields in the assertions, where anybody could insert anything. And free-form fields are never problematic, right? Like, no privacy issues at all. It also captures device-specific metadata. So if you took it on your phone, an iPhone, Google Pixel, whatever, that is part of the metadata now, and everybody knows you have a Google Pixel phone. Maybe that was part of the point, but I don't know. But anyway, my argument is that every one of these manifest fields is a privacy entry point, and we can quickly map those to issues that many of us are familiar with, right? So the signer certificate can leak identities. Timestamps can result in temporal correlation and profiling. Claim generator tools can result in tool fingerprinting, figuring out what a particular company uses without them explicitly saying it out. The actions history gives you the entire structural changes that were made to AI content, which means anybody can replicate those exact same actions in that exact same sequence to get a ditto copy of your thing without ever touching the original. The assertions are custom, not even going to go into that, and creator de-anonymization. So who took it, the latitude, longitude of the photo, what kind of device captured it, where they were when they did it, all of that stuff. So we are saying that these enable possible privacy threats. Now, naturally, we come to this collision course where regulations want us to be more transparent. Platforms want to be more transparent. Users want more transparency. But at the same time, the fields that are representing this transparency also introduce privacy leakage. So we have to collect less data, but we have to disclose more data. And any practitioner knows that those two things are kind of hard to maintain at all times. I also want to kind of not deal in absolutes here. There is a spectrum of this risk, right? Not every single AI-generated content contains these issues. On the lower side of the risk spectrum, we have fully synthetic generated images. Like you go to ChatGPT, you ask it to generate an image, and all it does is like, a few decent pieces of data around like, oh, ChatGPT generated this, put a watermark on there and send it out. It could be AI assisted where you took an original image and made changes to it, and now it contains some pieces of data about who you are, what you did, and also the original image, the ingredients that went into making that edit. On the other end of the spectrum, you have camera captures with AI edits, which disclose the largest amount of data around a user, their devices, their location, lat long, all of those fancy stuff. And the reason we are bucketing these into like different areas of the risk spectrum is because not all of them need the same level of controls when you're implementing these at scale. The engineering controls for each one definitely changes from tier to tier. And speaking of regulatory labels, I also want to make sure we spend a second on this, because deciding what labels your platform shows and why you're showing it gives you more insight into what level of controls need to be implemented. Labels, at least from today's industry standards and regulations, are meant to be contextual cues. They disclose that something was AI edited or generated, and they do not endorse anything around a particular tool or a particular methodology. They are currently not meant to be truth signals. We are not saying that this is fake news or real news. We are saying this was AI generated or edited. And making that distinction gives you a clear picture of what types of controls you need to implement and what fields you need to expose. We are not using this as a substitute for user literacy. You still need your large content platforms to continue the discourse on what exactly AI transparency means for them. And once we have this distinction set up in place, we know that these are the specific pieces of data we need to expose to the user, and these are fields that are superfluous and not needed. So going back to the controls, we discussed a few threats. Let's take a look at what each of those threats can be mapped to from a control point of view. Luckily, most of these things have pretty straightforward one-to-one mappings. So for instance, identity leakage, instead of signing it at a per person, per team, or a self-signed certificate, use org-level issued signing keys. This way, you're at least saying something along the lines of Google created this or Meta created this, rather than saying Sai Prashanth created this, right? Temporal correlation, course and the timestamps, we don't have to be nanosecond precision here. This is not something that requires that level of precision. The coarser our timestamps are, the harder it is for a third party to make temporal correlations or create a profile about our users. The workflow leakage piece, this falls in the middle end of the spectrum because it's not exposing user data, but it is exposing possible IP. And that can get into like sticky places. So minimize the actions, record only the ones that are relevant to transparency. In this case, we want to know if something was AI generated or AI edited, so focus on actions that tell you those things. Do not focus on every single action the user took. Tool fingerprinting, you can just be generic about it. You can say this was created by Gemini, or even at a higher level, this was created by a Google Media product, rather than going super in-depth into what model was used or like what kind of training was done on that model. Like, yes, that data is available, doesn't mean you need to use it. De-anonymization, this one's, I think most people would agree. I don't know, some people might disagree, but stripping PII is kind of like a nice idea. Like, no need to pass that along if we don't need PII. Covert channels, yes, use an allow list so that you're not passing along free-form data from a typical user all the way and putting it on blast on your large online platforms. The principle to follow would be minimize data by default, disclose by exception. And yes, I know I'm preaching to the choir. Please don't hold this against me. Coming to how the controls themselves travel. So in terms of what we saw earlier was all storage. And now we want to talk about how to have controls around the data travel. Cross-context linkage. Let me actually spend a second here, because an example might help us visualize this better. So let's say I take a product that I, like Gemini, and I run an image or a video through it, and then I upload it to TikTok, and then somebody reshares it to Twitter. I expect some level of anonymity when I do that. Let's say I put it on Reddit instead of TikTok, so that my username's like obscured and everything. But if somebody is motivated enough, they could actually track across these apps because the hash for the underlying AI provenance would match up. And they could actually trace this content back to me, even though I expected some level of anonymity. So during travel, it would be better if individual large online platforms actually made sure that they re-sign those manifests with new keys so that the same key is not being transmitted across. OCSP leakage, while this is on the rarer side of things, I believe in never trust anybody. So in this case, I would just suggest that large online platforms maintain their own hashing buckets locally, so that way OCSP stapling doesn't happen and your certificate provider doesn't know who your users are. Stripping of PII, which I recommended earlier, can also serve as a counterproductive measure, because now just because you stripped something, somebody might infer that it was AI generated in the first place, or there was PII, and that increases the attack surface. Publish stripping policies so that absence isn't read as evasion, and other platforms continue to trust what you're telling them. And finally, have retention limits on the transparency metadata that you're storing, so that way you're not inherently leaking them at some data leakage at some point. So the reason I'm pausing on this particular piece is that for the travel bit, it doesn't matter if you did a good job on your platform, because you need the industry to come together. You need all large platforms to work together and follow best practices so that this doesn't become a leakage issue across. So bucketing these things, identity risks, temporal risks, fingerprinting risks, and cross-contact risks. And I'll hand it off to Gayathri to walk us through a real-world example of how this looks like.
Cool. Thanks, Sai. I'm going to try and speak in 2x in the interest of time. But let's take everything you just heard and run it through one realistic scenario. A person takes a photo on their phone, edits it with some AI tools, for example, background replace, uploads it to one platform, and somebody else reshares it to a second platform. So going through the 4 stages, we'll watch the controls fire in order, and we'll also see 2 problems that don't show up until content actually moves through the ecosystem. So stage 1 is capture. The person takes a photo. Notice that no AI has been involved so far, and there's no C2PA manifest yet. But the file is already carrying a fully loaded privacy surface. The EXIF metadata is embedded by the camera firmware itself, the device model, the serial number, GPS coordinates, the exact timestamp, and the OS version is all exposed. So none of this is about AI for real, but this is what just cameras are capturing. And this is where most pipelines start their reasoning. They look at the bytes coming in and treat whatever there is the starting point. That's already a privacy problem before any AI tool touches the file itself. So a quick anti-pattern check over here. If we don't strip the EXIF at the stage, here's what happens. The GPS coordinates is going to travel with the file through every subsequent step, and any downstream consumer who looks at the file is they're going to be able to geolocate exactly where the photo was taken, and more often than not, it's somebody's home. So the ordering rule we mentioned earlier is non-obvious and bites a lot of the teams. The C2PA manifest signs over the EXIF, so if you strip the EXIF after the manifest is attached, you're going to break the signature. So strip first, sign second, so the order really matters. So the second stage is the AI edit. The user runs the photo through a background replacement tool. This is where the manifest is getting assembled. And this slide is showing a lot of the work. Every check mark that you see on the right is a control that we already discussed, firing in production at the right time. So the signer certificate is going to be at the org level, not user level. The timestamp is going to be course into the day. The action log is collapsed to a single AI edit entry rather than the full edit history. The tool fingerprint is a generic string over here. EXIF was stripped before signing, and custom assertions are filtered against an allowed list. So none of this is exotic. It's just discipline applied consistently. So if you want to see what the minimization is actually going to bring you, here's a side-by-side. So the left one is without the minimization with all of the content we discussed before, and the right is with minimization showing roughly 80% less identifying information. So this is the concrete payoff of the playbook. So stage 3 is the upload to platform A. At the ingestion boundary, the platform does 3 things in order. So first, validate the incoming manifest signature so that we know what the chain of custody is. Second, strip any assertions that aren't already on the allowed list. This prevents any upstream tool from having to smuggle any tracking payload. So the final one is the re-signing with the platform's own certificate. So transparency assertion is preserved end-to-end. The content is still labeled as AI edited, but the manifest hash is now changing. So that matters for the next stage we'll be talking about. So C2PA at scale brings cross-cutting risk beyond any single thread that we discussed so far. So right-sized compliance, every additional manifest field beyond what regulations require is privacy exposure. Longitudinal accumulation, internal transparency metadata retained over time effectively becomes content tracking data set. So even if it was never intended to be one. Adversarial scraping, bulk extraction of public manifests across an ad library or platform is going to reveal industry-wide AI usage patterns and individual strategies. The mitigation orientation across all the 3 steps is minimize at manifest, retention limit at the system, and aggregate at the public API. So this is the part we're actively working on, so we want to quickly flag it. Everything we just walked through only protects users of platform A. So if content moves to a platform that doesn't apply the same hygiene, the cross-context linkage and the inherited metadata risks is going to come back. So the platform by platform approach has a ceiling, and getting past that ceiling requires that controls to be in the standard itself and not just our implementation. There's active work that's happening in the C2PA conformance program to push the privacy controls, assertion, allow listing, re-signing semantics, manifest minimization defaults up into the conformance bar. So if you work on a platform that implements C2PA, getting involved in that program is one of the highest leverage things you can do, and we are happy here to talk about it after the session if you want to engage. So the final stage is the reshare. Someone who downloads for photo from platform A is going to repost it to platform B. So what happens next is entirely up to platform B's choice, and we get 3 very different outcomes depending on what they do. If they re-sign on ingest, cross-context linkage is broken, and the transparency label is preserved. If they pass through, the hash now links to 2 posts, that's content distribution graph, that's going to be exposed. And if they strip manifest entirely, it's going to be a reason that the absence of a manifest is going to be an evidence of tampering. So even when the stripping was not done with bad intentions. So I'm going to hand it off to Sai to close out.
I'll probably stop here and take questions, but I'll just put this slide on so it's like easy to have all the minimizations.